Hi, my name is Kashish, and today I will be going over the AP Biology curriculum. So today we're going to start with Unit 1, which is called the Chemistry of Life. So let me just start sharing my screen. All right, so first we need to talk about water. So the structure of water looks like an oxygen with two hydrogens attached to it. And this has a bent structure because as you can see, it literally bends right there. So that's why we say that water has a bent molecular structure. So in the water molecule, oxygen has a negative charge while these two hydrogens have a positive charge. And the oxygen is so negative compared to the hydrogens that it literally pulls the oxygen, it literally pulls the water molecule like that. And so that's also why it has a bent structure. And that also means that it has a negative charge, which means it's polar. Water can also attach to other water molecules. So let me just draw that. If acids negative and I wanted to draw on the charges again. So it can form hydrogen bonds to other water molecules. So let's write that in. Hydrogen bonds. And these types of bonds are actually the weakest. And the reason it's able to do that is because this positive charge and this negative charge are attracted to each other. So they're able to bond together. And these are actually the weakest types of bonds compared to covalent bonds, which are right here, which are the strongest types of bonds. Okay, so next we have to talk about a property of water called cohesion. So cohesion is basically when water is bonded to another water molecule. It's two like things being attached to each other. So this right here is an example of cohesion because it's a water molecule attached to another water molecule. And then the next property that we have to talk about is adhesion. And adhesion is basically when water attaches to a substance that is not water, that is unlike water. And so an example of this is a graduated cylinder. So let's say we had some water in here. Okay, so as we know, the graduated cylinder has a bit of a dip right here, right? And then it like these sides tend to creep up. And so the reason for that is because the water is actually attaching to the sides of the graduated cylinder, which allows it to creep up. But since the dip has nothing to attach to, it's like the water in that area dips because of that, because it has nothing to attach to. All right, cool. Next we have to talk about is the specific heat. So water has a very, very high specific heat, which means that it is extremely hard to heat up or cool down water. And that's a really good thing, especially in a environment like oceans. So let's say we had our oceans and we had some little fishes. And so it would be extremely hard to survive in an environment where the temperature is always constantly fluctuating and changing. So because of its high specific heat, the temperature is able to remain pretty stable. And also this can be seen in coastal areas like California, where the temperature is pretty stable near that ocean. And a category under this high specific heat is the heat of vaporization, which means that which is like talking about boiling basically. And so it's very, very, it has a very, very high heat to boil water. So, okay. The next property that we have to talk about is density. So if you ever seen the Arctic or Antarctica, you see the water, and then there's like a glacier. This is my little glacier, right? And so a glacier obviously is solid, it's ice. So you would think that it sinks, right? But as we know, it floats. And the reason for that is ice is crystal lattice structure. Just draw it really fast. Yeah, so this crystal lattice structure, basically through the hydrogen bonds, the molecules are able to separate more and spread out, which allows it to be less denser than the actual liquid water, because as we know, when molecules are spread out over a larger area, that means it's less dense versus like tightly packed together. And yeah, that is why ice is able to float on water, which is a good thing, because we don't want that ice, we don't want the water to be freezing and then just constantly sinking, because that would not be good for the aquatic life down below. Okay. So the last property that we have to talk about for water is the fact that it is the ultimate solvent. And so that means water as a solvent can dissolve more substances than literally anything else. And so substances that follow that property of being able to dissolve in water are called hydrophilic, which actually means water loving. So they like water. They are able to be dissolved in water, like I just said, and they're also charged, which means that they are polar. Polar. And then the types of substances that do not follow this, they do not solve in water, are called hydrophobic, which means water hating. They do not like water. They are, it's literally called, it's the direct translation would be water fearing. So they do not dissolve in water, and they are not charged, which means that they are non-polar. So an example of a non-polar or a hydrophobic substance would be like oil. So yeah. All right, so now we have everything down for water, and we have to move on to carbon. Okay, so carbon basically looks like this. So let's say we have a carbon, and it can have 4 bonds to any type of like molecule or any type of atom, I meant to say. And these bonds are extremely strong. They are covalent. They're extremely strong. And they make covalent bonds because carbon tends to bond to other substances that are similar to its electronegativity. And so carbon is found in all living organisms, all of them, because it forms many essential compounds. It can form these strong bonds, and yeah, it's very, very essential to life. And a way to check if a substance is organic or not is seeing if it has carbon. If it does not have carbon, it automatically classifies it as inorganic. But if it does have carbon, then it can be organic. All right, so that is all I have for you today. I hope you enjoyed this lesson, and I hope you tune in next time when I keep on going over the biology curriculum. See you then.